Morning class. Today's video we're going to go over simplifying radical expressions when we have to the 1/2. So anything raised to the 1/2 power can be rewritten as the square root of everything inside. So a squared raised to the 1/2 is the same as the square root of a squared. Well, now let's ask ourselves, a squared, how would I get that? That would just be multiplying a times a, right? Well, when we take the square root, we just need the single digit that multiplied by itself equals that. So we just need 1a, and the square root of a squared is just a, because a times a is a squared. Now, let's say we have an odd number here. This is a to the third. So 1 raised to the exponent of 1/2 is the same as the square root of a to the third. Now, to get a to the third, it's actually a times a times a. Well, when we take the square root, we can take out 2 of the same digit that multiplies by itself, right? So here's 2. A times a would be a squared, but we would need 1 more left over. So we would get a square root, and we still have, we still have 1 left over, so a would still be on the inside. All right, let's try this again. Number 3, we've got a to the 4th raised to the 1/2, so it's the same as square root of a to the 4th. Square root of a to the 4th, well, how did I get a to the 4th? That would be like a squared times a squared, right? Which means I can pull out 1 when I take the square root, and those both cancel out. Now, if I have a to the 5th raised to the 1/2, that is the square root of a to the 5th. Well, for a to the 5th, that's going to be a squared times a squared times, and there's 1 more a left over, right? So these ones, we'll take square root of that, so we'll pull out an a squared. Those cancel out. I have an a left over, so I need a square root of a. Last two, a to the 6th raised to the 1/2 is going to be the square root of a to the 6th. Well, to get a to the 6th, using the product rule, that's a to the 3rd times a to the 3rd, which means square root is a to the 3rd, and then when we cancel those out, there's nothing left over, so we don't need a square root anymore. Let's take a to the 7th and raise it to the 1/2, which is the same as the square root of a to the 7th. Now, for a to the 7th, that would be like a to the 3rd times a to the 3rd times another a. Well, there's our perfect square. So a to the 3rd and a to the 3rd. I have 1a left over, so it stays in the radical. So, the question is, do you see a pattern? If we have even powers, which is like power of 2, power of 4, power of 6. All you have to do, you will get perfect squares. So all you do is divide by 2. Now, what did we see every single time we had an odd number? 3, 5, and 7. Well, there was always 1 guy left over after we divided by 2. So, for the odd powers, here is the rule. You divide by 2, move to the outside, and you're going to have 1 remaining inside. So for the even powers, you're just going to divide by 2 because it's a perfect square. For the odd powers, you're going to divide by 2, and you're going to have to leave 1 remaining inside. Every single one of these had 1 left over on the inside, right? Because that didn't cancel. I'm going to stop the video here. We're going to do some more examples on the next video.